Have you ever really stopped and wondered what's going on deep inside your phone or your computer? I mean, yeah, we see apps, photos, and messages, but underneath it all, our devices are speaking a language of pure numbers. So today, we're going to pull back that curtain and decode the fundamental language of our entire digital world.
Okay, so what in the world is this? It looks like a completely random jumble of numbers, right? Well, believe it or not, this is what a simple little GIF of a cat actually looks like to a computer. It's not random at all. It's a language. And by the end of this, you'll actually understand what it's trying to say.
So that's the big question, isn't it? How on earth can just two numbers, a 1 and a 0, be enough to power everything from streaming movies to the most complex video games? Well, the answer starts with the smallest, most basic piece of information a computer can possibly understand.
It all comes down to a single, tiny switch. This one concept is the absolute bedrock of all modern computing. Seriously, everything, and I mean everything, is built on top of this one super simple idea.
It's called a bit, which is short for binary digit. The easiest way to think about it is to just imagine a single electrical wire. It can either have electricity flowing through it or not. It's either on or it's off. That's it. That is the entire concept. It's like the atom of information.
Now, to make this useful, we just assign numbers to those two states. We say that 0 means off, like this unlit light bulb here, and 1 means on, the bulb is lit. And just like that, we have a way to represent two distinct ideas, 0 or 1, true or false, yes or no. It's a really simple start, but it is incredibly powerful.
Okay, so one little switch is cool, but a single bit isn't very useful on its own. The real magic, the real genius, happens when you start lining up a whole bunch of these switches together. Because when you do that, you can build something much more powerful, a system for counting.
To get how computers count, let's just quickly compare it to how we count. Our normal decimal system is what we call base 10. Each position is 10 times bigger than the last one. You know, you've got the ones place, the tens place, the hundreds, and so on. While binary is just base 2. So instead of multiplying by 10, you just multiply by 2. Ones, twos, fours, eights, and on.
So let's see this in action with the number 9. In binary, it's written as 1001. So why? Well, you just look at the places. We have a 1 in the 8's place, and we have a 1 in the 1's place. 8 plus 1 equals 9. See? It's that simple. Now, your computer does this math billions of times a second. But the key takeaway is that using this system, any number imaginable can be represented with just ones and zeros.
And here's where it gets kind of mind-blowing. The more bits or wires you use, the bigger the numbers you can represent, and it grows incredibly fast. Look at this. With just 8 bits, you can represent 256 different values. But with 32 bits, you can represent over 4 billion different values. This exponential growth is the secret to handling really complex information.
Okay, so counting makes sense. But what about words and pictures and sounds? This is the part where it all clicks into place. You just have to remember one thing. For a computer, everything, from the text in an email to the colors in a photo, is just a number.
So how do you represent text? It's simple, really. You just create a dictionary. We all just agree that the number 1 represents the letter A, 2 represents B, and you just keep on going. And just like that, any word, any sentence, any book can be stored as a long sequence of numbers, which of course we already know can be stored as ones and zeros.
And pictures? It's the exact same idea. Every image is just a big grid of tiny little dots called pixels, and the specific color of each one of those dots is represented by, you guessed it, a number. And when you realize that a single photo is made of millions of pixels, you start to get a feel for the sheer volume of numbers being processed all the time.
And this applies to sound, too. As software developer Federico Gomez Suarez puts it, sound is just a waveform. A computer digitizes it by taking thousands of measurements per second along that wave and, you guessed it, storing each of those measurements as a number. Higher quality audio? That just means the computer is using more and more precise numbers for each measurement. So we have these incredibly long streams of bits representing everything. But, to work efficiently, computers don't want to handle them one at a time. That would be way too slow. They prefer to group them up into a standard, manageable chunk.
And that standard chunk is called a byte. A byte is simply a group of 8 bits. You can think of it like a computer's word. While it processes everything as individual bits, it really prefers to handle them in these convenient, byte-sized groups of 8. Now, this is crucial. The byte is also the smallest chunk of memory that a computer can locate directly. So think of it this way. Every single byte has a unique address, kind of like a house on a street. This system allows the computer to instantly find and grab exactly the data it needs whenever it needs it. It's all about organized storage. So let's circle all the way back to that scary string of ones and zeros from the beginning. It's not so mysterious now, is it? We can see it for what it is, just a sequence of 8-bit bytes. Each one of those bytes is a number that tells a single pixel in that GIF exactly what color it should be. And just like that, the mystery is solved. And that really leaves us with an amazing final thought. Every video you watch, every game you play, all of it. It's all built from nothing more than a massive collection of simple on and off switches. So if all this digital complexity can come from the simplest possible idea, what's the actual limit to what we can create with it?